Welcome, data people. We are Zuma. My name is Matt, and this is Data for Good. This podcast is brought to you by Zuma. Zuma is a dedicated recruitment company for senior data, insights, and analytics professionals, connecting you with Berlin's most influential companies. The Data for Good podcast is for the world of data analytics and engineering, giving you access to the thoughts and opinions of Berlin's most successful data people. Today, we are joined by Kunal Jha, data engineering lead at Codility. What an episode this is going to be. Kunal is going to inform us about strategy, the tech pillar in data, and discuss ownership and quality. Kunal, welcome. How are you?
Pretty good. Thank you. Thank you for an amazing introduction. How about you?
I'm very, very well. Thank you. Very well. So we are in October already. How is the rest of the year looking for you and the team?
Well, it's exciting time to be in the year. Like Christmas is coming up, but there are still a couple of things you would want to still wrap up at the end before you finish off this year. Overall, with the whole macroeconomic situations, things have been more challenging than normal. However, I would say it's an exciting time to be a data engineer, considering you want to be more efficient, you want to be more competitive, you want to be more innovative, and at the same time be relevant in the market. So all in all, very exciting.
Absolutely. I think we are pushing towards the end of the year, but what has been unraveling throughout the year is kind of the unfulfilled potential of data engineers, and it's really been starting to be realized. So it's quite an exciting time for everyone in this area. Now, for the podcast today, we're going to start off with quite a big topic. So data strategy. It is an area that you have a big passion for. But first, for those who aren't in data, and to start off in simple terms, what is a data strategy?
Well, if you ask me to define a data strategy, I would say the data strategy is more of a long-term plan, like that defines technology, process, people, rules that are required to manage any organization's information assets. Like any other strategy, building a data strategy is quite essential for any organization to be competitive in their space, be relevant, innovative, amidst all these things that are changing. So it's not just about collecting the data, but it's also about organizing and acting on your data to meet your business goals, unlock value for your organization, improve operational efficiency, processes, make sure you're able to get relevant, fast decision-making process, increase your revenue stream, improve customer satisfaction, and stuff like that.
Amazing. So as a company, building your data strategy, where do you start?
I guess like for me, it is very important to think of data strategy holistically, because the needs of the business changes and the situation around the business itself changed quite a bit. So it's important to think of it very holistically from the beginning, with an additional parameter that it can evolve and change over time. In my experience, there are mostly like 6 pillars of data strategy. One of the first one being the ownership of strategy, right? Like who owns the strategy? It's important to think about who will be the driver of the strategy. How does it align with the business goals? Who develops the strategy? Who are the first class citizen? Like who will be the ones who will be using this data? How will it impact the business? And who will be the one driving it, right? The second important pillar over there is about the operation model, like who will be the key stakeholders. So we have the driver in place, but who are the key players who will be involved in this data strategy? What is the role of business function, product, data teams, design teams, right? How would you want them orchestrated in a manner that is cohesive in general for the data strategy to function well? The third pillar would be about deriving value. So For a successful data strategy, it's not about just optimizing it on the engineering perspective, but we need to treat data as an asset, right? There's like all these buzzwords going around, like data is oil, it's gold. We need to treat data as an asset. So it's very important to think while deriving the strategy as to how we can determine the value of data, right? There might be some very low-hanging fruits which one can deliver at the beginning of the strategy to get a bigger buy-in, right? So dumping data into the lake is not a strategy, in my opinion. It's just establishing that single source of truth. One needs to understand what kind of KPIs they would need to measure to derive value, and how would you impact the business, right? So all of this data strategy in the end is supposed to help the business, and it's important to make sure that the value that you get out of data is aligned with the business goal. The fourth pillar for data strategy would be infrastructure, like the technology intensive part. How would you deal with the huge volume in the variety and the velocity of data? So some data strategies might be focused more on the real-time stuff. The others are across regions. How would you do metadata management? How do you control costs? Because you're collecting all the data, it's very easy for the cost to boom out of proportion. So infrastructure plays a big role in deriving how you would go about that data strategy. The fifth pillar would be data as a product management. So companies like Meta, Google, they have set a great example of using data as a product, but it's not that prominent concept in other spaces. What I mean by when I say data product management is you just don't want to just create pipelines and move data around from one place to the other to serve one analytics dashboard, but to actually use data to get the insights of it and develop data as a product like any other product of the company. Right? You want to serve both your internal and external customers. You want to see how you can create value and serve data as a product, like sending insights for your customer and making a more data-driven product throughout the company. And the last pillar, although I say it's the last, but I believe it's the most important one, is people and culture. Like culture is the key in strategy. So like a strategy can, most of the successful strategy in my experience have been driven by a very strong people and culture around data, not just driven by one single team. Like there's no central data team, in my experience, cannot drive a very successful data strategy. It has to come around from business, from the companies in general, right? Like how would you organize your data teams? How would you organize your product and engineering teams? How would you determine your design your analysts and data scientists? So yeah, I guess that would be the most primordial element where you would want your to increase data literacy in your teams. You want to upskill different people to make data-driven decisions, and this upskilling doesn't need to happen only around the data team, but also even up to the higher level. So it's like a top-down. I would say it's a combination of top-down to bottom-up approach, where you meet somewhere in the middle, where you know that there's a data-backed decision, right? So having this data-driven culture is kind of very important to have a successful data strategy.
There's a lot to consider, and there's obviously a lot of value in using these principles. But you mentioned that the most important is the people side, the people and culture side. How do we use our expertise in the data world to convince people that we need to drive a data-driven culture?
Well, that's a very good question. So, and it's probably one of the first and the most important hurdles you need to pass, like to convince people who are not related directly to the data world, to convince them that you need a data strategy and you need to upskill your people because it's an investment for the company. My approach to this in general is like you want to do it in an iterative, gradual fashion. So as I was mentioning, like deriving the value out of data, it's
Yeah.
quite important to uh, get the like those low hanging fruits. Like there are small things that you can, which requires a very little investment, and then you can deliver value to the business, right? So, in general, the data strategy should be defined in a way that you show value at the end of every iteration cycle. The size and the duration of the iteration cycle would depend probably on the scope of work, but in general, if business sees the value and we are able to deliver success, it's quite straightforward to get a buy-in after that, right? So um, it's important, like whether it's analytics project or machine learning project, I guess it is very important to deliver value based on the success criteria and the metrics defined by the business themselves. So like business defines what does success look like at the each end of each stage. And then when you make an investment, it's important for the drivers to make sure that that value is delivered.
Nice. And if we were to put that into real world scenarios, if you think back over your career, what would you say your favorite low hanging fruit was that triggered an evolution of a company's data ideas?
So most of the companies, they need analytics. Like analytics is one of the people would want to, like there is internal analytics and customer analytics. I believe like internal analytics is one of the easiest low hanging fruit you can tackle, because the stakeholders are very contained. The definitions are very much defined. People know what they're doing. It's part of their day-to-day job. So the requirement gathering phase is pretty straightforward. And then identifying the data sources and just cleaning up the data is, especially for internal analytics, is pretty, I would say, is one of the most common low-hanging fruit you can find in the industry. And once you have those dashboards going in and you're improving the efficiency of the people within the organization, then exposing it, taking it to the next level. I've seen that once you give people the taste of this data, they always ask for more, and then that's how you spike the interest. So yeah, I would say like tackling the internal analytics would be one of the first ones we can think about dealing with when we start with the data strategy.
Nice. So show people the data for efficiency internally, get them to see how that works and the value that can add. And then from there, you can start introducing more complex data processes to improve the company. Perfect. So even to people within data, there's a lot to take in when it comes to technology and a data stack. It's a big pillar, the tech pillar. So what are the differences? We have streaming and real time versus batch. Should we start there? What are the differences in these areas?
Yeah, sure. So like the way I envision an entire data stack is there is like an ingestion point that is streaming or batching, how you would want to ingest. Then there is the storage on top of, so you ingest data, you store it somewhere, then you run some calculations and compute on top of it. And then there is the data artifact, the output part of things, where you have data science and analytics. So maybe we can definitely start from stream and batch, which is the first part of the pipeline. So I guess, yeah, I guess the ingestion probably depends on the timeliness of data, like how fresh the data needs to be and what kind of artifacts are you trying to deliver at the end of the cycle, right? So if you're looking for real-time analytics, or you're looking for gradual batch analytics, like something that is aggregated over an hour or something like that. So I guess it is very SLA driven on SLA around delivery of data to each of these artifacts. So streaming is more like real-time use cases where you push in your data in near real time through some event buses or like technologies like Kafka or Kinesis, Pulsar, and things like that, where you are pushing in the events. Then, if you decide to do some real time analytics, you're looking at trying to add some querying on top of it. So, like aggregating data again on near real time, and then feeding into some analytics dashboard. So I guess it is very use case dependent. The companies also do tend to consume these real-time events and then aggregate them as batches on the data lake layer, where you're joining, like, I don't know, an hour or so of events, creating an insight from it, and then delivering that information. So I guess both batch and stream have their own challenges. They have their own there are different set of pipelines, and the technology set is quite different. Most of the use cases, depending, I guess it also depends on the business, but mostly people initially tend to start with batch processing, get the data delivered, set up their ETL pipelines around it, and then eventually evolve into streaming and more real-time use cases.
So it sounds like streaming and real-time data is maybe the future. It has high overhead costs at the moment. So don't go running to streaming if needed. Batch if you're just doing daily analytics, for example, and it's not business critical. Do you see the future of analytics that all data will be real time?
Well, it's a very tricky question, but I guess it will depend on the business, right? So if you are in a business where you need to show your customer, your internal and external customers, real time what's happening, and I guess this is something what we have, like events in Google Analytics when we try to do the website traffic flow. So I guess they have like clear real time use cases. Where you want to send events from your website, and then you want to analyze how a user is interacting with your website. And then it needs to happen almost near real time. While there are other use cases where you would want still a batch data, like how much revenue did you make in the last 1 week, or the revenue probably doesn't change every 1 minute or something like that, right? Like you probably
It'd be great. It'd be great if it did.
For sure, yeah, definitely. So yeah, things like that would definitely makes more sense to process them in the batch. And we need to understand the difference that the batch versus real time comes at a very different cost. Like batches, you're triggering a compute, so the compute cost per batch is in most cases significantly low than real time cost. Like in real time, you have constant services that are running, and they need to run in a cohesive fashion. They cannot fail at any point. Like you need to be very reliable. Versus in batch, you have compute that triggers every once in a while. It's more cost efficient, and also you get to retry in most of those cases. So the amount of reliability or the extent of reliability for these pipelines is, in my opinion, a little lower for batch as compared to real time, because in real time you have more risk of losing data. Things in the downstream application failing more as compared to batch. So I guess it's a cost balance between the two.
Nice. It's a topic we could probably talk about for much longer. A question that we've been asked is to go through a lot of buzzwords that are shared, especially with maybe job requirements and job setups. So data mesh, data warehouse, data lakes, these are all things that are thrown around. What are the differences to someone who's not in data?
So yeah, like talking about the storage of data, like the first one that came, so I'll probably just go chronologically, like how. So the data warehouse was like our traditional setup. Like when we moved, even before this Hadoop big data world, there was the data warehouse. And how would you see a data warehouse was like It's a data store where you know more or less precisely what you want from the data, what are the possible use cases of the data, and then you also know the shape of the data, right? So like it's very structured. You know what you extract data from your source, you change the shape, you model them, like create clean columns and tables, and you organize them in a way where it's just optimized for decision making, right? So data warehouse was primarily focused around something, I love the term, I read about it a couple of years ago, and it's called decision support. So it's not just building dashboards and stuff, but also to enable decision making. And that's why data warehouse was very popular, I would say back in the 90s, early 2000s. And what it did was it tightly coupled storage of data and compute of data together, right? With a very specific data format. You want to connect it to a BI tool, create nice dashboards, and it's very optimized to deliver this. So it's very fast query. There are modern data warehouses that are making this coupling a little loose, but you still have to worry about the data format. Like you need to ingest data in a certain manner to optimize your queries, to make sure that you have all the data that is needed to deliver a particular dashboard or analytics artifact at the end of the cycle. From what I see is like maintaining a data warehouse became very complex because of this tight coupling. It became very complex to maintain data warehouse, right? And you are collecting a lot, you need a lot more data, which might not be needed for data analytics like machine learning or data science, than real-time analytics. And you would still want to aggregate this data and use the data in different format, which is not necessarily analytics. So the agility of delivery became an issue with data warehouse. It's not to say that data warehouse didn't do what it was designed to do. It's just that the use cases increased with big data, the velocity and the variety of use cases. And that's where the data lake steps in. So you can think of data lake as something that decouples the storage and the compute. So you focus on getting in the data, and then you assume that you can do any number of use cases from that data. So the compute engine or the calculation part doesn't really matter, doesn't play a role. Like the idea should be that storage of data should be flexible enough to deal and work with all sorts of tools that come into the market. And it's quite undefined structure, right? Like it's very easily evolvable. Different people can use it for different use cases. They can transform data based on their use case. And the users of data lake, again, are very different than data warehouse. So data warehouse are mostly business analysts and stuff, while in data lake could be data scientists, engineers, like product engineers, who prefer to get a more granular raw form of data to evolve their use cases. Also, because of the processing and the time, so data warehouse, because it is optimized for a certain stack, it usually is more costly as compared to data lake. Although this is now changing, and we are trying to bridge the gap with these new lakehouse approaches, which is the third layer that is now in the market, is bridging the gap between data warehouse and data lake. So there are different companies like Databricks and Snowflake that are bridging these gaps. So like you're trying to create an analytic layer on top of data lake itself, and trying to make get the best of both worlds into one. Yeah. And finally, like now the new term you mentioned about data mesh. So finally, talking about data mesh. So data mesh, I would say, is a new type of data platform architecture that embraces the ubiquity of data in the enterprise by leveraging a domain-oriented, rather self-service design. What I mean by that is you have a single data platform architecture with a lake and data warehouse, and you want to replicate this architecture across different domains. So like different, like same parent company having multiple smaller companies would probably be looking at doing something like a data mesh, where it doesn't mean that people are allowed to do whatever they would feel like about the data architecture. It's more about the maturity of the organization, that like we have figured out what is our sweet spot when it comes to data infrastructure. What is our data? We have a significant level of data maturity, and then we just let different data teams across organization manage the data in the fashion that is optimized for that function.
So it sounds like it's removing the bottleneck of pushing things to the data specific teams and centralized teams, and working towards a more self-service approach.
Precisely. I mean, self-service approach is probably one of the most common way of removing bottlenecks around the data team, because it's depending on the volume and the amount of use cases, it is very easy for a central data team to become a bottleneck in this entire flow. And but it definitely, with data mesh, it is quite important to understand that there is a significant amount of cross team, cross-function data ownership and metadata challenges, and it also is driven primarily from the data culture we were talking about earlier. What you would definitely expect from all of these different data platform across organization to have some sort of a producer-consumer contract, right? And these are definitely driven by the culture. People understand, take the ownership of the data. They try to establish a contract between the people who are producing the data and consuming the data, and this has to be done in a distributed self-service manner.
And as we move towards self-service, you touched on it then, data quality, data ownership is going to become even more important if it's not already vital. So what are the best practices to ensure data quality from the consumers?
Well, I believe like data quality comes in steps. So ideally, yes, we would like to have like the best quality of data, but when it comes to development, I guess it has to be done again in this iterative fashion, right? Like data quality, there are different layers of data quality. Like you would want data freshness. That means data should be refreshed within a particular agreed upon SLA. It should be consistent. It should adhere to business logics and definitions of what, for example, like what does customer means to an organization. So having this common definition of the same customer across all these functions like finance, marketing, product, it's very important to define those entities. Having the metrics definition, for example, how do you calculate NPS score, things like that. So like having these metric definitions so that not different departments are not reporting the same metric differently. And even if you extend it to data science, then what does the quality of ML models look like? What is the success criteria? How do you define it's not just about accuracy, like how much confidence you have on a particular ML artifact. So I guess all of these happens in different layers. One of the, I would say, relatively lower layer to address would be schema validation and consistency across different functions. So establishing like the basic layer of single source of truth. And needless to say, like this has already a great impact on business, especially the ones that are just kicking off the ground. So like most of the startups I've seen, they start by plugging in their analytics on the production databases, and then the product teams, they just change the data, and then it kind of breaks the analytics board. So decoupling these sources and how the analytics evolved from the product teams is kind of like the step one for data quality. And then going from there you iterate as to what good quality looks like for each business case, and then you try to address it proactively or reactively. Again, it's a trade-off between cost and the return on investment, things like that. So you just iterate over it one small step at a time. So you define what quality means. Like the next step would be evaluate the existing baseline, improve, and then feed it back to the business.
And who is responsible for overseeing this?
I guess it depends on the business and the size of the data team. In a more self-driven, mature data culture approach, I guess it would be every single business function that defines it. But in most cases, the quality is defined by the business, right? The person who is looking at a particular dashboard and detects anomaly or doesn't feel like the data is being data is not of the adequate quality to serve the business need, whether in terms of freshness or consistency or accuracy. I guess they are the ones who always drive it from the or at least initiate this quality process. In a very mature big data organization, there are quality teams like the quality QA, very similar to QA in product. We have data QA where there is a governance and quality teams who are looking specifically, proactively for data quality in general. They're integrating certain tests and stuff like that. But I guess it also depends on where the data quality is. Like, so data quality problems can arise from infrastructure failures. The second category of those could be like the data owners, like the people who produce the data, they are changing data without informing their customers. And the third source of failures could be like the data engineers, the data developers. They try to do a code change or change some business logic, and that caused the failure to propagate. So I guess it will depend on which layer the quality problem arises, and then accordingly, the corresponding team, and based on the org structure itself, it's either the data team or the owner team, or in very few rare cases, it could be the consumers also fixing or unifying the metric definition or something like that.
Interesting. I think it's a topic we could probably dive a lot deeper in again. But time has absolutely flown, and it's been a valuable conversation. I'd like to wrap it up with a final question. So, how could someone who's not within the data world in a company, how would you advise them to become more aware of a company's data strategy?
So if the company already has an existing data strategy, in that case, I would propose a person. So as I said, it has to be very business driven, right? So if I'm a part of business and I have nothing to do with data, but the fact that I understand that I need data, I need to find my place in the entire data strategy key players, if I may. So where do I lie in that chain? And how can I contribute into the data strategy so that my function or my current role can benefit more from this data? Like, as I said, like business plays a very important role. So if I'm a business person and I have a data requirement, it goes a long way for the technology teams to understand. So propagating that understanding to the technology teams is kind of primordial, like telling them exactly what are the success criteria for a particular use case looks like. And of course, just in the terms of data strategy, understanding this iterative approach in which the data strategy is being executed, or if not, then pressing for it, is something that would also be quite relevant for the technology team, because technology teams usually do not understand the business, right? Like they are far away from the business. So it's kind of important to bridge this gap. And I think that's the most challenging part of any data strategy, that business needs to hold hands with the technology function, so that they can drive the data strategy together.
So first, understand how you can make an impact with the data that you're consuming, join the dots and try and bridge that gap between the business and the technology teams. Wise words. Well, you've taught us a lot today, and there's a lot of points that we could have spoken a lot longer for. But I do think these topics will lead quite nicely onto a future podcast, and we would love to have you on again on the future. But unfortunately, that's all we have time for today. So thank you very much for your time and insights, Kunal. It's been educational for us all, and I think topics that everyone will want to know more about. And to the listeners, as always, if you have found today interesting, do let us know, and also drop your questions and feedback into the comment section, and we'll pick some out for you for us to answer on future podcasts. And don't forget to like and share, so we can get the message out to as many people as possible. But for today, it's bye from us. Thanks once again, Kunal.
Thank you very much. It was a pleasure talking about it. As you mentioned, like, we can talk about it all day. So I'm looking forward to any future sessions.
Definitely, your passion definitely comes through. Thank you, and to everyone, ciao for now.
Well, thanks, ciao.